For many years, something strange has been happening at the edge of our solar system. A group of icy objects far beyond orbiting Neptune drifts in the same direction. Their orbits are aligned in a way that suggests the presence of a massive body that controls their movement, forcing them to form a crowded structure. Such coherence is statistically unlikely without external gravitational influence. And no, it is not Neptune, not Pluto. It's something much more distant, much more massive, and completely hidden. Astronomers call it the ninth planet. It's a mysterious world which could be 5 to 10 times more massive than Earth and orbits so far away that sunlight hardly reaches it. And most surprisingly, new signals are appearing from old data, new discoveries, and strange objects that may finally indicate where it's hiding. Or have we been wrong all this time? Is there really a ninth planet? Finally caught? Is this the biggest scientific ghost hunt of the decade? Let's find out. Back in 2016, two astronomers Mike Brown and Konstantin Batygin turned attention to something strange. They weren't looking for a new planet. They were trying to understand why some objects in the outer solar system are behaving unusually. This were neither planets nor comets. They were so-called extreme trans-Neptunian objects, or ETHNO for short. Frozen stone bodies rotating far beyond Neptune. But the strange thing was that many of them had non-random orbits. Instead of being scattered in all directions, their trajectories were grouped together. They had a similar slope and seemed to point in one general direction in space. This should not be the case. In a stable solar system, small objects at such distances should have chaotic, scattered orbits, not neatly aligned. The only explanation that made sense at the time was that they are being affected by something massive, something we haven't seen yet. Brown and Batygin conducted calculations. If this mysterious planet exists, it should be at least 5 times more massive than Earth, and possibly 10. Its orbit would have to be gigantic, about 400 to 800 times farther from the Sun than the Earth's orbit. For by comparison, Neptune is only about 30 times farther from the Sun than Earth. So this object wouldn't just be distant, it would be in a region of the solar system that we barely know about. They called it the ninth planet, not only because after Pluto's reclassification, it would be ninth planet, but also because no other explanation agreed with the data from the mouth of Mike Brown, the man famous for the discovery that kicked out Pluto. It sounded a bit ironic to the Planets Club, but it wasn't just speculation. They did not claim the existence of a ninth planet for the sake of making headlines. Their scientific work detailed mathematical calculations and showed how the gravitational influence of this hypothetical planets could explain the clustered orbits of distant objects. Moreover, they suggested that it could also explain the strange inclinations of the orbits of some known bodies. In particular, why some smaller planets tilted at unusual angles. This has triggered a global hunt. Telescopes around the world began scanning the sky for this invisible giant. Astronomers looked through old data archives, hoping that the ninth planet could have been detected earlier simply without realizing it. Joined in the search even amateurs, using online databases, algorithms, and citizen science platforms to find something suspicious. And for a while it seemed that the more we looked, the better the picture came out. It was discovered more extreme trans-Neptunian objects. Some of them had similar orbital alignments. A few even moved in retrograde orbits in the opposite direction to most other bodies. And again, mathematical models pointed to the same thing. Something big, very far away, and hidden in the darkness. But the problem remained. No one ever saw the ninth planet. Years passed, new predictions appeared, and more areas of the sky were excluded from possible search areas. But every image, every scans, every attempt to find it ended in nothing. And yet the clustering of orbits was real. And every time a new trans-Neptunian object was discovered that fit this pattern, the theory gained additional support. At this point, the evidence was not yet conclusive, but it was compelling enough for Planet 9 to become one of the most debated ideas in planetary science. Not because it was fascinating, but because it was the only explanation that agreed with the mathematics. However, not everyone agreed, and that's where things started to get complicated. The idea of a ninth planet didn't last long indisputable. That doesn't happen in science. As soon as a theory gets attention, researchers from all over the world began to test it. Some tried to confirm, others to follow. That's how science works. If something is true, it should stand the test of time. All attempts to prove otherwise. So what did they do? They launched computer simulations. Lots of simulations. Using powerful models, researchers recreated the solar system, but this time with a hidden ninth planet far beyond Neptune. They gave it the right mass, distance, and the shape of the orbit according to the predictions of the theory. And in many cases it worked. The models showed that the very type of orbital clustering that we observe in real data. The strange behavior of distant icy objects became clearer when you added a ninth planet. But then the first serious opposition appeared. Some researchers, including Samantha Lawler and Jean-Marc Petit, argued that this clustering may not be a consequence of the existence of a hidden planet at all. It could just be a coincidence. Their argument was this: the number of known objects is small, and most of them have opened up a few specific sky surveys who observed the same areas at the same times of year. This could create observational bias. If you only look in one direction, you will only find objects that point in that direction. This like standing in the forest with a flashlight, shining it at one point and saying, all the trees are in this direction. Maybe, or it's just where the light falls. It's led to a growing split. Some scholars remained convinced that claiming that the clustering is too consistent to be random. Others were convinced. They demanded better data, a larger sample of objects, and a wider view of the sky before accepting the existence of a whole new planet. Meanwhile, new simulations were being conducted, not only for support for the ninth planet hypothesis, but also to find alternatives. One group suggested that the strange orbits might be caused by a massive disk of small objects acting together, a kind of gravitational soup that collectively affects other bodies. Another group proposed the idea that about summer stars in the early stages of the history of the solar system could disrupt the orbital order. And there are also proponents of modified gravity, a small group that thinks maybe we don't need a planet at all, or disk. Perhaps gravity itself behaves differently at large distances. Most scientists don't accept this last idea, but the point is that the ninth planet never was not the only explanation. It was simply the purest version that agreed with the mathematics. And yet, the longer she was not seen, the more critics began to ask, if it exists, why haven't we discovered it yet? Over time, this question has been increasingly louder, especially considering that despite the narrowing of the predicted area, in the search for the ninth planet, telescopes found nothing again and again. It was vast swaths of sky have been surveyed and still empty. The theory was not dead, but it wasn't getting any stronger. It was stuck in a strange intermediate state. There's still no better explanation for clustering. Did not exist, but the lack of direct evidence was beginning to wear down the community. This went on for some time until something unexpected appeared, not in the sky, but in the old data from many years ago, and it changed the course of history. For a theory that began with such fervor, the search of the ninth planet eventually hit a wall. Not because the math fell apart, but because the sky refused to cooperate. After the 2016 publication, astronomers around the world began scanning the areas where the ninth was predicted to be located planet. Brown and Badigan used models to estimate its orbit. Inaccurate position, but a pretty good idea of where it might appear in the sky and how bright it might be. This was enough to start a series of targeted searches using of the best instruments available. Mr. Star, Subaru Telescope, Dark Review Energy Survey, and even archival data from the Wishla mission. Part of the problem is how incredibly dim Planet 9 would have to be. If it exists, it is probably 100 times farther from the Sun than the Earth is. So, it reflects very little sunlight. At that distance, even an object the size of Neptune would be almost invisible to most telescopes, unless you know exactly where to look. Also, the ninth planet would move very slowly. It would drift across the sky for weeks or months, which means that most programs designed to detect fast-moving objects would simply not notice it. Despite this, it remained the hope that the ninth planet could have been accidentally detected during older surveys, simply not realizing what it was in the images. So astronomers began to delve into the mission's archived data and times the 1980s Japanese infrared satellite Akari from 2000, and the WISE mission, NASA's 2010 infrared telescope that scanned everything sky. These surveys did not record the planet directly, but left behind thousands of mysterious heat sources, small, blurry, slowly moving dots. The problem was that most of them turned out to be galaxies, noise, or image artifacts. But what if were there more of them? That didn't diminish the interest. After all, even if it wasn't the ninth planet, the question has still remained. How many more unknown objects are hiding in this area? What else could there be? What haven't we noticed yet? Meanwhile, other reviews continued to narrow down the possible options. In 2021, the team analyzed data from the observatory from the VK Transcend facility, which has been taking wide-angle images of the northern sky for years. They filtered slowly moving objects with appropriate brightness and distance. As a result, more than half of the region where the ninth planet was expected to be found was excluded, at least for objects brighter than the apparent magnitude of 21.3. Then came the Kamos 1 review, a lesser-known but specialized project that also found nothing. This meant one thing. If a ninth planet exists, it is either extremely dim, either it is hiding in the far southern part of the sky, or its orbit is so different from our expectations that we've been looking in the wrong place all this time. In other words, the evidence hasn't disappeared, but it should cool down. The more we searched, the more options we rejected. This is not a defeat. Yes, science works. But it also meant that there were fewer and fewer places to look until something new appears. Not just in the data, but in the real sky. Strange just now an open object that has given rise to a whole series of new questions. After years of deaf corners, the last place anyone would expect a breakthrough was old data from cold, obsolete satellites. But that's where the most interesting clue came in. These satellites weren't designed to find planets. They scanned the sky in infrared light, looking for stars, galaxies, dust, and heat sources. But thanks to the depth and breadth of observations, these data arrays have become a kind of digital archive of space history, a place where something previously missed could still be lurking. In early 2025, a new analysis of the IRAS and Akari archives revealed something strange. It was small, it was dim, but it existed and was present in both datasets with a difference of about 20 years. And most importantly, it moved very slowly, but it moved. It was this movement became the key. Galaxies don't move like that, stars either. The noise is even worse. But the distant solar system objects move in this way, especially those that are on at such distances at which the ninth planet is predicted to be located. At first glance, this seemed to be exactly what astronomers had been waiting for, a possible direct. The object was not bright, but it was quite consistent with what was expected from a cold planet hundreds of light years away. Astronomical units from the sun. It had the correct infrared signature, not hot, silent, only slightly warm like a frozen planet radiating residual heat. Of course, this caused a surge of interest. News headlines instantly picked up the topic. Articles began to speculate whether this was finally the long-awaited confirmation. But the capture did not last long because the orbits did not coincide. The predicted orbit of Planet 9 is elongated but relatively flat, inclined at approximately 15 to 30 degrees to the main plane of the solar system. The new object had an inclination of over 120 degrees. This is not just a small difference, it is actually up by a thread compared to everything else. It was moving in a retrograde orbit, that is, in the opposite direction, the motion of most planets, with a much greater inclination than ever expected for the ninth planet. And that's the problem. Could the ninth planet have such an orbit? Technically, yes, anything is possible. But then all the original models, the same ones that explained the clustering of distant objects, would have to be completely reviewed. They would no longer explain the same patterns, and if the object does not explain clustering, then it can't be Planet 9. It's something completely another. Mike Brown, one of the authors of the original Planet 9 hypothesis, quickly came up with an explanation. He stated that this was definitely not their ninth planet. In his opinion, the object was real, maybe a large trans-Neptunian object or something else unclassified, but not that one. that they've been looking for all these years. So, in a strange turn of events, the most interesting object found in recent decades has not solved the mystery but has made it more complicated. Because now we have two problems. We still haven't found the ninth planet, and at the same time we've discovered something new, which also doesn't fit into the picture. This is exactly the awkward position this discovery has left us in. It's progress, but seems to be in the wrong direction. However, not everyone considers this a dead end. Some argues that this just shows how little we know about the outer region's solar system. There may be dozens of similar unknown objects. Maybe Planet 9 isn't the only one out there. Maybe the solar system is much stranger than we thought, and we've only scratched the surface. And that raises a broader question. If we find such strange things just by looking at old data, what else we could have missed? Because even if this object is not the ninth planet, it proves one thing. There is something out there. While attention was chained to an infrared mystery from the far reaches of the solar system, arrived. Another surprise, this time not from the old archives, but from a completely new discovery 2017. On paper, it didn't seem like anything special at first. It was just one distant dwarf planet added to growing list of extreme trans-Neptunian objects, but its orbit immediately caught the eye. This object was moving along an absurdly elongated trajectory, reaching almost 1,600 astronomical units at its farthest point from the Sun. By comparison, Pluto is only about 49 astronomical units away. This object was in a completely different region of the solar system. Its orbit was not just distant, it was extreme, long, elongated, tilted. An orbit that literally screams. Something powerful must have thrown me here. And of course, the obvious question arose, is this further evidence the existence of a ninth planet? At first it seemed that yes, because such orbits and objects thrown onto strange, highly eccentric trajectories were predicted within the framework of the ninth planet theory due to gravitational shocks over millions of years. So this object looked like the proof everyone had been waiting for. But a closer look revealed messed up. Its orbit did not correspond to the same clustering that the original theory of the ninth planet was based on. Moreover, 2017 OF21, as if he fell out of the general picture, as if he obeyed completely different rules. He did not, was consistent with other objects. It did not reinforce the pattern, it destroyed. And this created a new problem. If the ninth planet is to explain clustering of extreme objects, but we constantly find new ones that do not fit into this scheme, or do not weaken. This is the whole hypothesis. This is the most unpleasant moment. Every new object found in the outer solar system theoretically should either strengthen or weaken argument in favor of a ninth planet. The more objects follow the expected pattern, the higher the confidence becomes. But when something big comes along, like in 2017 year, and doesn't fit into the picture, it starts to raise doubts. Do we see a consistent gravitational influence? Or maybe we're just selectively paying attention to objects that fit under the model, ignoring those that don't? Some researchers have begun to suggest that the model itself, the pattern may be a statistical illusion, the result of observational bias, caused by where and how it is we who survey the sky. They claim that objects like 2017 ALF21 is exactly what you should expect if Planet 9 does not exist. Chaotically scattered orbits are formed by billions of years of small interactions, galactic tides, and chaotic motion. This doesn't mean that a ninth planet has been completely ruled out. It just means that not everything strange about the outer solar system can be automatically attributed to it. And yet it's hard to ignore the fact that that object 2017 exists. Something put it there. And regardless of whether that something is a ninth planet, a star that passed by millions of years ago, or just a long-lasting gravitational drift, it's a clue, but not one that solves the mystery. On the contrary, it makes it more complicated. This discovery also gave weight to another idea. Perhaps we are looking for one big planet, while the reality is much more chaotic. Perhaps there's a whole population of medium-sized objects there, not massive enough to be planets, but quite capable of disrupting gravitational equilibrium. If so, then the ninth planet may not exist, but its effect is quite possible. In any case, 2017 reminded everyone of one thing. We still know very little about what's out there outside. Each new discovery adds data, but not always clarity. Sometimes the mystery only deepens. Let's assume that Planet 9 is real after all. A massive world 5 to 10 times heavier than Earth, orbiting at a distance of hundreds of times larger than the Sun than we are. Then the simple question arises: how does it ended up there? After all, according to all the rules, it shouldn't have been there. According to generally accepted models of formation planets, at such distances in the solar system, there simply wasn't enough material to form such a massive object. Beyond the orbit of Neptune, the Sun's influence weakens. The dust disk becomes thinned, processes slow down, ice fragments could form there or comets. But full-fledged planets is already too bold a hypothesis. So if Planet 9 didn't form where it is now, so where did it come from? One of the leading ideas is that the 9th planet formed much closer to the Sun, perhaps in the region Jupiter or Saturn. Uranian chaotic times of solar system planet formation constantly interacting with each other, exchanging angular momentum like bumper cars in slow motion. In this chaos, the 9th planet could have been thrown out. Gravitational interaction with one of the gas giants could push it into the outer regions of the system. But instead of finally to fly into interstellar space, as is usually the case with ejected planets, something unusual happened. She was caught. She couldn't escape completely. She ended up on a very elongated but stable orbit, far beyond the other planets. It became a kind of an exile from a solar system too far away to be easily seen, but close enough to remain bound by the Sun's gravity. This idea, not just a guess, computer simulations confirm it. When researchers simulate the dynamics of the early solar system, they often observe scenarios in which 1 or 2 planets are ejected into distant orbits. Some of them even end up in orbits very similar to those predicted for 9th planet. This is not the most common result, but it is not uncommon either. According to some, it is estimated that about 1 in 10 early planetary systems could have completed formation with an object similar to the 9th planet. But there is another scenario even more interesting. Perhaps the 9th planet was never part of our solar system. Imagine a young sun that forms inside a dense star cluster, surrounded by dozens or even hundreds of other young stars that are born from the same cloud of gas and dust. In such a crowded stellar maternity hospital, planets and debris would fly everywhere. And in these chaotic conditions, it is quite possible that our Sun would simply steal a planet from another star. This idea, known as planet capture, is impure. Simulations show that in dense star clusters, stars passing close to each other can capture planets, or even tear them out of orbit during close encounters. If the 9th planet originally orbited another star, and our Sun passed close enough in the right direction moment, it could be pulled into our system and fixed in a wide, distant orbit. According to the results of one study, the probability of such a capture within the first 100 million years, the existence of the solar system could reach 20% under favorable conditions. This scenario also explains well why the orbit of the 9th planet, if it exists, is so tilted and elongated. It is not formed in the neat flat plane of the solar system, it came from outside, and this means that its orbit will not necessarily be consistent with the others. It will be slanted, strange, unpredictable, exactly as modern writers describe it. Observation. Some researchers believe that a combination of both scenarios is possible. Perhaps the planet formed in the solar system, was thrown outwards, and then its orbit was further perturbed by a passing star, or several small interactions gradually formed into one large one. The cosmos is not always gives us definitive answers, but the main thing is this. There are realistic ways in which a 9th planet could exist. They don't violate the laws of physics. They don't need to be rewritten. Theories of planet formation. All it takes is time, chaos, and gravity. 3 things that were abundant in the early solar system. So, even though we haven't found Planet 9 yet, we know that it could exist, and we understand how it could end up where it is. The only thing we lack is direct proof. After almost a decade of theories, simulations, and dead ends, the search for Planet 9 is approaching a turning point. Not because someone has already found its saw, but because the tools we have used so far have exhausted their possibilities. We scanned most of the visible sky, looked at decades of archival data. Huge areas were excluded. The ninth planet would be, and still nothing. This is where Vera Rubin's observatory comes into play. Located in Chile, it is not yet fully operational, but when it is, it could change everything. Observatory. The Ruby is radically different from most telescopes. It does not focus on a single object, but equipped with an 8.4 viewing telescope, and the largest in the world with a digital camera that will scan the entire southern sky at night in high detail. Its main program ideal for finding slow-moving dim objects like of the ninth planet. Ruby combines speed and extraordinary sensitivity, covering large areas of the sky in a single image and detecting much fainter objects than previous surveys like Mr. Stars. The most important thing is that the observatory will re-observe the areas themselves are not 10 years old, which will allow you to record slow drifting objects that move almost imperceptibly against the background of stars. According to Rubin's estimates, it is capable of detect objects up to 24th magnitude. If a ninth planet exists and is within about 800 astronomical units, it should be bright enough to be detected. And if the observatory finds nothing, that will be the strongest evidence that the ninth planet either does not exist or has completely different characteristics than predicted. However, it is Rubin who gives which had never been seen before. A deep, clear, and uninterrupted view of the southern sky region. The ninth planet is most likely hiding. So we are getting closer to a crucial moment. Either this planet will be found, or the hypothesis will have to be finally rejected. And that is what makes the current stage so important. After all, it is not just about a new discovery, but about the completion of an entire scientific history.